thing I want to point out is the learning plan here for the next couple of days, just so you guys are on track. So we are on the Wednesday, Thursday, 18th one here. So we've got a short section of notes we're going to go over, and you guys will have some more time to work on the homework. And then on Monday, we will have our errors quiz. So the homework that I was just going over is due Sunday night. So you still got a couple of days to work on it. If you didn't finish it, you can still hit me up in tutoring or whatever, and I'm happy to help you. You will also notice that we're not doing any notes on the quiz. So we're going to have some time in class to do what some people have been asking for, and that's some multiple choice test corrections. So I'll get more details about this as the other classes get to do it on Friday. But basically what I'm hearing is that you're going to be working in small groups of students who have the same sort of grade that you have on the multiple choice, and you guys get to work together and help each other out and make corrections. I believe, don't quote me on this, but I believe even if you passed the multiple choice section, you can still do corrections against point that. So this is not limited to people that made less than a 70. But again, don't quote me on that yet, because I'm waiting to hear the other two teachers always go first, and they work all the kinks out. So I got to be as consistent as I can with them. And so I got to wait to hear exactly what they're doing. So that's kind of the plan for Monday. It's the quiz and then test corrections. And then next week is a weird SAT day that they didn't do last time. It's back again. So we'll make a video of the two means with inference notes. It'll probably be Miss Nichols making the video, because I'm doing the one for the on-level statistics. You'll watch the video and you just work on the homework that day, and you guys should be good to go as far as attendance credit. And this is for my seniors and sophomores that are not participating in the SAT day on Wednesday next week. So it was going to be originally like the third way long time ago. Then they moved it to this Wednesday. So again, as of right now, we won't have class here at the STEAM Center next Wednesday. But you never know, that might change again like it did last time. So just be on standby. If it does, I'll try to let you guys know. And then Friday that week, we'll have our last set of notes here, the math superiors notes, and work on homework. So we don't have anything really stressful coming up as far as like examinations or anything, except for this errors quiz on Monday. So just try to be as ready for that as you can. And then the last week here in March that we're wrapping things up, we'll have a practice quiz over the notes I'm showing you guys today and the notes that you'll see next Wednesday. And then the Thursday, the 1st of April, April Fool's Day, you get to do a test. So that's going to be the next big thing there. Keep an eye on your due dates for the homework. I changed it in Canvas to reflect our class because it's always set for the A days originally. So again, your homework is due Sunday night, the 21st by 11:59 p.m. So if you're already done, then you can start working on today's stuff as we go through it. Any questions on the schedule or any confusions? So make sure you guys are on the right page. We're in the year where tests are going to be happening all the time, not necessarily involving this class. So we're going to be obviously flexible as we're going through these weird times with campus-wide testing for different things, et cetera, et cetera. Okay, so let's talk about today's notes. Two sample proportions with inference. So you might recall back to Unit 6 when we started this in February, right before all the snow stuff hit us. We started looking at p-hats and p's and trying to figure out what the confidence intervals were, a upper limit and a lower limit. We're going to do the same thing here, but we're going to do it with two samples now. So it's going to change our thinking a little bit. We're no longer looking at one percentage and trying to determine where the real percentage is in real life. We're going to be looking at two percentages, and we're now going to be finding the confidence interval of their difference. Meaning we're going to be comparing them. Did my second treatment or did my second whatever increase or decrease my original percentage significantly? So whereas before 50% was kind of our middle point, where if we had a confidence interval above 50%, we could say for sure that somebody was going to win an election or that this was successful more often than not or things like that. Now we're going to look at 0 as more of that threshold because we might have negative percentages because we're comparing two things and maybe the second one did so bad that it reduced things, or we're going to be looking at positive percentages as a good thing that the second thing increased what we wanted. So keep that in mind. You may see some negative numbers on some of the homework examples. The ones in the notes don't have negative numbers. But the ones on the homework may. I have not looked ahead enough yet to see how far that they go. Okay, so here's a pop quiz to see who's paying attention with these things. What are my assumptions whenever I do a confidence interval with proportions? Who remembers way back to February off the top of their head? There were 3 things we had to check for. Independence was 1. Randomness was 1, and one more. Normalcy. Very good. So do we remember how we tested for normalcy with percentages? It was the formulas, right? What were those formulas? You guys remember? NP and in 1 minus p. Very good. So those are going to show up again on here. And so is the random one on here, but we're not going to worry about independence as much on this one. All right. So you're going to have 2 independent simple random samples from the population instead of 1. Or you're going to have 2 randomly assigned treatments. So these are in your notes, already filled out, but you can add things in there as you need to. And then you're going to have the populations being at least 10 in. We don't need it this time. Not that it's not important. AP exam just doesn't care about it. So we're not going to stress it too much. But you are still going to test that both samples are approximately normal. How do I verify that in my assumptions? We just said you're going to have n times p is greater than 10 and n times 1 minus p is greater than 10. But we're doing 2 samples. So what else we got to do? We got to do it a second time. Now, as we're going through this, there's going to be a portion coming up here in just a minute or two where we're going to throw out the formula and say you can type everything into the calculator and press enter. And this is the point where you can hate me, because you can also use these things I show you guys for the old stuff that we did in Unit 6. The problem is whenever you do Unit 6 stuff, you still have to write down all the formulas. For Unit 7, we're going to take some of that away, and we're going to say now we're looking more at your assumptions and your conclusions because the calculations can be done digitally. Okay. So if you want to send me hate email later because you're like, Mr. G, if you just showed me this earlier, my life would have been easier, feel free to do so. I get paid to deal with that kind of torture. So have it at it. So here was the formula that we would use if we were doing things by hand. We would have p hat 1 minus p hat 2. So remember, when we're doing these things, we are comparing the difference between 2 percentages. We're no longer looking at 1 percentage and guessing its likelihood of an actual value. We're now looking at 2 percentages and constructing a confidence interval on the likelihood of their difference. So it's a different way to think. So as we're going through this, keep that in mind. The z would go where it's supposed to go to. And then here's our nice fancy standard deviation now. P hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. Anytime you don't know p hat or p, you just replace it with that one on this one. So this is exactly the same formula we did before, except we just got this extra additive on it. And notice underneath the square root, regardless of what I'm doing here, what am I doing here? Addition. Okay, so that's still true. We don't want negative numbers. We don't want to end up in Algebra 2's fantasy land of imaginary numbers. I never got those things. Like, why are we creating a number system that doesn't exist? All right, so this is still considered your standard error, a fancy term for standard deviation. This is considered your margin of error. So we could say M equals, and we could have that formula again, okay? So you could write that next to it if you want to. I'm going to give you guys the shortcut version of this again because I love you so much. And then the first part would be your 2 samples. So the question will be, Mr. G, how do you know which sample to do first and which one to do second? It don't matter. Typically, I just say whatever they have first goes in the first one, and whatever they do second goes in the second. The calculator is going to figure it all out for you. All right, so that formula sure does look like a lot of work, Mr. G. I wish there was a formula built into the calculator that all the formulas could do and blah, 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 blah. Well, there is. We just didn't tell you about them. So we're going to go to the stats button. We're going to go to the test button, and we're going to see all of the options of things we could have done, including things previously. So you can do one, yeah, go for it. You can do 1 confidence interval from the very first Unit 6. You can do 1, yeah, see, Zindy's giving me the evil stare right now. You can do 1 t-test sample, just like we did last time. You can do all the stuffs. All the things are in the calculator. In fact, Skylar accidentally stumbled upon them about a month ago, and I told him to keep it quiet. He did a good job of finding it. So what does this mean for our class going forward? You can use these programs now anytime you want to find the correct answer. I highly encourage it. What you cannot do, and this is the important thing, is go back to Unit 6 and do corrections and retakes and not do the steps like we did the first time. So you can use it to check your work on those if you're doing corrections, but you still have to write out all the steps and the formulas like we did. And in fact, I'm going to encourage that going forward in order to get credit for your work. Because remember, AP exam raters will give you partial credit if your work is on there. All right, we're going to use today with our notes the letter B, the 2 prop Z interval. So what can get confusing in the calculator is there's so many different versions of what the stuff we have in there. We got to make sure we pick the right one. So we're going to go through that one today. Again, all of the other formulas are also built in. So for example, a t-test refers to a 1 sample t-test with means, which is what we just took our test over on Unit 6. Make sure you differentiate between a test and an interval. Okay, so a test is a hypothesis test, an interval is a confidence interval when it's written in your calculator. Again, you cannot use these for quizzes and tests from Unit 6. If you don't show the formulas, you will not get any credit. So Cindy can't go back and be like, oh, I'm gonna do corrections now, just type it all in and get her answer. She's still gonna have to go through the steps of writing out Z equals, P times 1 minus P over N, all that stuff, and still get that and then still verify it. Now, does that mean now she has to go into the inverse norm and do all that stuff? And she can use the calculator programs now to find the answers, but I still need to see the formula. All right, some tips for navigating the program. Like I said, most of the stuff's written in your notes. I'm just going through it. You can highlight things as we go through that sound interesting to you. For means, you can type it in a couple different ways. You can type in the stats yourself if you have them. So what I mean by this is, if I go ahead and I give you the X bar, and I go ahead and I give you the sample standard deviation, and I go ahead and I give you the average and all that stuff, then you can plug it into the program and press enter and do your thing. Or if I go back to one of those rare examples where I give you a data chart with all of the X and Y values, and you have to go and check that they're normal, you can plug in that into your list and it'll read it from that too. So the calculator is pretty nice. It will do it from either format. So you don't have to go and figure it out. Here's going to be the important part for a lot of this stuff. For our percentages, especially today, the letter X in your calculator is the numerator of your P1 or P2, P hat 1 or P hat 2. Okay, so this is written down on your deal, but just make sure you highlight it just so that you know where it's at, or put a star next to it or something. And the letter N in the calculator is the denominator. Okay, so this is kind of like a manual on how to use the program so that they can actually be useful to you. Here's the cool thing. For the confidence intervals that we're about to do, when it asks for your confidence level, you can just type in the level as you see it as a decimal. We do not need to go back and add the tail in it. So if it says, Connor, make a 90% confidence interval, Connor's going to put in 0.9. It will take care of business for us. When the program does the calculations, it will add the tail for you. Yay! Which is why I didn't stress doing it too much when we first started. For a two-tailed hypothesis test, you don't need to multiply the p-value by 2. So remember at the end of our hypothesis test, if we did a two-tailed test, we had to take p-value multiplied by 2. The calculator will do that for you as well. So whatever answer you get will be the already calculated by 2 p-value. So be careful. So the program can be a little different than what we were doing, and you might get numbers mixed up. For percentages and proportions, if they give you p hat as a decimal, because sometimes they will, you're going to have to then multiply that decimal by the sample size in order to figure out what X is. So you're going to have to reverse engineer it and make it back into a fraction. Because the calculator will not accept a percentage. You have to give it to it as a fraction every time. It's not that hard to do, but just be aware of it. So if I tell Laura, 62% of the time people are successful out of the 500 people we interviewed, she's got to multiply those together to figure out what that 62% is. It's not difficult, but that's the only trick you got to watch out for. Round it to the nearest whole number before you plug it in. So if you get some weird decimal, you can round it up or down. On this one, it's okay as necessary. All right, if we were allowed to use this calculator before, why didn't you show us this last unit? So this is all Ms. Nichols' writing, but again, you can send hate email to me because we all work together as a team. And these are the reasons why we don't show you guys this for Unit 6. Number one, we want you to understand the calculations first before you start just plugging them into the calculator. Number two, there's multiple choice questions that actually just have you solve up the equations without solving it. So you would need to know how to do that anyways. And for questions that require you to find sample size or something else related to the margin of error, such as confidence level, you still have to understand how the formula works, as a calculator will not give you those answers. So I can't plug things into the calculator and say, how many people should I talk to? It doesn't have that problem. So we still have to reverse engine. Ms. Nichols says, lastly, because it's good for you, she's actually right on this one, because routinely and historically, year after year, our AP exam scores are better and higher than just about everybody in the state. And they're on level, if not higher, than most people across the country. So as much as it sucks to go through Unit 6 and be tortured by Mr. G with all those little things that I take off points for, when you get to the AP exam, you're like, I was prepared, my teacher was evil. And then you feel better about your day. Okay, so last year we got lots of 4s and 5s from people who stuck with the program and did it. I'm not saying everybody who sits in my class is going to get a 4 or 5, because not everybody puts in their best effort. But those who do, and those who went through the whole process and all the steps and understand now completely what the formulas and everything do, you will be so much better for this than the average person who's going to like Salina ISD, and there's only one teacher with like 3 classes and they've all been doing the calculus all the time. They're going to sit a question in the exam and go like, we never covered this. And they wasted their time and money. So again, hate email can be sent to brian.jenikin@alnisd.org. I'll put it into a spam folder. Anyways, So just letting you guys know that, yes, these things are here, that you can use them when you're doing your test. They will help you speed up your process so it doesn't take you 20 minutes to answer a question. But remember, you still got to do formulas and all that kind of stuff. So what are you required to do on the AP exam? So this is for AP exam people only. We will use these standards for our grading in class, but for you AP people, just know that this is required for you. On a hypothesis test, you're going to have to still state your hypothesis. Okay, HO equal, HA equal, and that includes defining it, where P hat 1 is equal to, or P hat 2 is equal to, or average is equal to, whatever. For the confidence interval, you still have to state the test name, and for the hypothesis test, state the test name. So this is going to be on top of what we're doing before. So today we're doing a 2-sample Z inference. You have to write that out as this is the kind of test I'm doing. The AP rater needs to know what you're doing, what's your test. Okay? And this includes your assumptions, randomness, normality, all that good stuff. So don't forget all that. Step 2 or 3, depending on which one you're doing, you still have to show the formula you're going to use, the appropriate numbers and all that good stuff. All right, so instead of showing the formula all the way out and written out, you can just show the test name, and then give out the answers and all that stuff. So that's kind of nice. You don't have to work all of those steps out by hand anymore on your paper. And then you obviously still have to do your conclusions. Okay, so those are still going to be required. So with all of that in the back of our brain and with all the hatred in my direction, let's look at one more thing, and then we'll start doing these examples together. For confidence intervals, your p-hats need to be in fraction form and the interval itself. And for hypothesis test, p-hats in fraction form, z, p-value, and alpha. So these are the minimum requirements right here. If you want to highlight these, smiley face and whatever, these are the minimum requirements for numbers shown on these two things, confidence intervals and hypothesis test. So if you're like, what numbers do I need to show, Mr. G? For confidence intervals, I need to know the p-hats in fraction form and the interval itself. What's the lowest, what's the upper number? For hypothesis test, I need to see the p-hats in fraction form, the z-score, the p-value, and alpha. When we get to the hypothesis test with means, we'll switch that to the t-value. Now, here's the big trick here. Little star next to this one. Make sure you call p-value what it is. Don't just say p equals. Your calculator is going to just say p equals, because it's very difficult for them to write in the whole word p-value. So they're just going to say, Laura, p is equal to, and she's going to know that means that's her p-value. But she can't just put on her paper p equals, because we've already got a p. That's the one up earlier, that's your p-hat, or that's the actual percentage. So she still has to make sure she writes out p-value. Students every year forget this, and they lose points on both the AP exam and in class. Ms. Nichols says it's a pet peeve of hers because she's actually been a rater before on these, like she's actually graded people's AP tests. It's not a pet peeve to me. I just don't want you to get points taken off on your AP exam. So you're not making me angry when you don't do it. I just feel bad for you because you're throwing away freebies on your test. Okay, let's do an example. Community hospital. Always feels like, I look at Claire and Maddie when I talk about hospitals. They're probably tired of me doing medical things. I'm probably like way off on all my stuff. The Burden Center is experimenting with a new plasma compress treatment. They took a random sample of 316 patients with minor burns that had received the plasma compress treatment. And of these patients, it was found that 259 had no visible scars after the treatment. They then took another random sample of 419 patients with minor burns that received no plasma compress treatment. For this group, it was found that 94 had no visible scars after the treatment. So basically what we got going on here, I'm going to pause for a second and talk out loud. We've got two samples that happened. One got some special plasma compress treatment, one did not. And so what we want to see with this confidence interval is what is the percent that we would expect increase or improvement of visible scar reduction based on the treatment versus no treatment. Okay, so this is a very legitimate thing. So we're going to create this interval or this percentage at 90% so we can get an idea roughly of what we would expect as a general population percentage increase and reduction of scars after you've been burned if you get to use the plasma compress treatment or versus if not. So here's our assumption. So you got to start with your title at the very top. So in the space you got, make sure you write down that you are doing a 2-proportion Z interval. They need to know which test you're doing. Assumptions. Number one, Connor said it correctly earlier. We have to test that they are random. So we have 2 independent, randomly assigned treatment groups. Check. SR random because, and it's met. I don't like that on these slides. It leaves out the the titles, it bothers me. So this should say, and then this is my pet peeve, I guess. This should say random because they look for that on the AP exam. I don't know why on the slides it didn't show it. Then we also have to check that they are normal. So both distributions are approximately normal because or since, and then you put your little stuff underneath. Okay. You don't have to really worry about which way you organize these. I like to go vertically. This one goes horizontally. So on my paper, I can show you in a second if you guys want to look at it. It's hard to read. I got 316 and 316, and then I've got the 419 and the 419. So that's the way I organize it. If you do it this way, it's not bad either. What you got, Connor? Yes. So your assumptions are still going to be very important. Very good question. Yes, sir. If you allow me a second, I can flip over to what I got on my my camera here. You can see. So mine's kind of squished because there's only limited space there. But yes, I still have the name of the test, the assumptions, random because. So without looking at all that yet, here's everything I got so far. If that helps you out. I still do the little check marks. You don't have to if you don't want to. It just makes me feel good that I checked something off the list. So. All right. The other thing it says that you need to do, and I'll put the actual bigger one up there in just a second so you can read it. If I'm looking at my notes, the other thing it says I need is, all right, what other numbers do I need? I need the p-hats in fraction form, and then finally the interval itself. And so without looking at my final answer yet, so I can show you how to get in the calculator, there's my p-hats in fraction form. So p-hat number 1 is 259 over 316, and p-hat number 2 is 94 over 419. So just make sure you put those on there somewhere so they know what the heck is the Laura comparing. Sample 1, sample 2. All right, so this jumps right into the answer. So I'm going to go to the calculator in a second and show you how we got 0.5464. I don't know why it rounded to 5. I used 4. And 0.6442. So that's the final answer to this. So notice I didn't put up there my formulas and I can do the calculator now. So I'm going to show you guys how we go from what we had to this in the calculator in just a second so that you guys know all the steps and all the fun. And then the last thing will be our conclusion, which mine is very squished in there. So I'm going to put it up on the screen so you guys can read it. All right, everybody got their p-hats? Let's look at the calculator work and see how this works. All right, so you go to your calculator. First thing you need to do is find where all your tests are located. So your tests are located now in the stat button. So hit stat and go over to test. There they all are, all of them in their glorious form. A regular Z test, a regular T test, a regular percentage Z test. The one, we're not gonna do that. We're not doing a Z test yet. But this is the one from that we did before. You got your Z intervals, you got your T intervals, you got 2 samples. We're gonna use those later. What we want is letter B. They're all in there. You just have to go back and kind of play with them. You'll see which one we want. So letter B is the one we need right now. A 2 proportion Z interval. Press enter. All right, my numbers are already typed in because I've already used it once today, but you guys can type it in for yours. So if you're looking at your example here, you can see where my numbers come from. So what is p-hat number 1? It has an X value of 259. What is p-hat number 1's denominator? 316. So remember, X is the numerator, N is the denominator. So again, if I give a Laura 62% of people, whatever, she's got to convert that to a fraction. All right, p-hat number 2 is the 2's. What is the numerator? 94. What is the denominator? 419. At what confidence level do we want to figure out the percentage difference between the 2 treatments? We want to figure it out at 90%. So what do we type in for C level? 0.9. Questions? So without doing anything fancy with all the formulas, we just go down to here, we press enter, ta-da, there's our stuff. So the answer is the very first line there in parentheses, 0.54639 and 0.6442. So I rounded it to the 4 decimals to be consistent. You can write it as the 5 if it makes you happy. That's what's on the notes slide. It even goes so far as to tell you, hey, look at that. That's your decimal percentages if you're curious. No, this is the notes. And then it reminds you of what your original sample sizes were. So everything's right there. So if Laura is curious of what the percentage was of success rate of reducing scars of plasma treatment patients, she knows it's 81%, 82%, whatever, did not show visible scars, whereas only 22% of people that didn't get it had no visible scars. All right, questions for me on the calculator? So if you didn't have one of these fancy calculators that can do this before, you're probably really going to want one now. So make sure you come to the STEAM Center at home learners if you don't have one. We will have these available for you guys for the AP exam to the best of our ability. I can't make too many promises about the June 10th one yet, but for those seniors doing it or other students doing it in person, we will do our best to have those available. All right, we okay with this? Isn't that much easier than doing on the formulas? Technology. So the thing is, you understand how it works. And so like I said, you can send me all the nasty hate email you want. I know I took into all your social media and video game time, but now you're going to be good for this AP exam. You can get that college credit, and I just saved you lots of money, so you're welcome to. Okay. Let's look at the conclusion at the bottom here. So the conclusion gets a little lengthy because now you're talking about the comparison between two things. So what does this little interval tell us here? All right, if I'm Claire or Maddie and I'm working at a burn unit, I'm not saying they are, I'm just picking on them because they're medical people. Then what they can see from this percentage is by giving somebody a plasma compress treatment, they can expect on average a 54 to 64% increase in the reduction of visible scars after being burned. That's what this is telling us, versus not getting any treatment whatsoever. So if I were them, I'd probably be like, yeah, I'm kind of excited about this because people having visible scars after burning, that kind of sucks. Again, I don't know if they're going to be burn victims or not. They might want to help children, which hopefully that's not the case. With the burn, that always makes me sad when the poor kiddos deal with that. All right, so there's your conclusion. We are 90% confident that the population proportion of all people who will receive the plasma compress treatment and have no visible scars minus, all right, so remember, we're comparing two things. There's the minus. The population proportion of all people who receive the control treatment and have no visible scars is between 54,639 and 64,416. So the conclusions are going to get a little lengthier, but all the math work is going to reduce significantly. All right, I'm going to pause, let you guys write this. Questions, comments, concerns about formatting or things that need to be replied. So what you see on the screen is basically the bare necessities. Again, my pet peeve is they didn't put the labels here. Random because, normal because, but. So I would add that, but everything else looks good. This will give Connor what he needs for credit on an FRQ question like this. All right, once you guys get done writing this, we're going to talk about the second part here based on the interval that we just calculated. What is it telling us? I just thought of something kind of weird and clever. If I was doing my notes digitally, I could copy this PowerPoint conclusion and just pop right in my notes. I'm sitting here waiting on people writing. You can just go, and then it was all right there. It's in your notes. You just got to highlight it. I mean, I know muscle memory and things, but just thinking of lazy student, Mr. G. All right, everybody good? Anybody still need the words? Okay. So based on the interval you just calculated, is there sufficient evidence to suggest the plasma compress treatment is more effective than the controlled treatment? So on this one, this is what I was talking about earlier. When you're looking at your intervals now, you're no longer looking at 50% as the yes, no answer. You're now switching your mind down to 0% as your yes, no answer. Because negative percentages would tell you what? That it's not effective or worse. And positive percentages tell you that there's at least some improvement, if not really good. Okay. So you got to look at it a little bit different than we did with the just 1% thing. So that's where our answer comes from. Since the entire interval is positive, so notice I didn't say above 50%. Since the entire interval is positive, that means the first treatment has a higher population proportion of success than the second treatment. So if I got a really big negative number on this one, and I'm like, that doesn't make any sense, then I just flip my numbers because I just did them in the wrong direction, right? And so Because if you look at your p hats, your p hat 1, your p hat 2, 259 people reduced scars versus only 94 people reducing scars when they were given the plasma treatment. So I'm trying to test if it was more effective overall as a percentage. I'm going to put it first. All right, questions before we look at some more fun stuff. Again, if I get too excited about this stuff, you guys just pull me down off the rafters here. Like this is, to me, this is the, like once we've gotten to this point, we're into the real business of statistics now. Like this is where the money's made. I'm able to put a bunch of junk together, come up with a conclusion, hand it to them and say, Claire, start treating that plasma compress treatment on them poor kids that come in. We don't want no scars. Claire's like, I got it, Mr. G. You taught me how to do this. I already figured it out before you did. Because she's smarter than me anyway. So. I always joke, I'm only smarter than you guys in this stuff. Everything else, you guys are smarter than me. And not for long. You guys are pretty much at the same, getting to the same knowledge I have on this stuff. So as far as basics. All right, anybody still writing? Okay, moving onward to our next example. So on example 2, we're not necessarily going to do a whole nother, comparing one percentage to another percentage. We've already got an example on that. On number 2, we're asking the question, can we figure out what sample size is needed like we did before? Okay, so before you had one percentage and I gave you the new fancy formula and you kind of plugged everything in, you pressed enter and it said you need to interview like 24.6 people and you rounded up 25 people, whatever. So same idea here. Suppose the researchers want to estimate the difference in proportions of people who are against the death penalty in Texas and in California. So we got 2 populations here. We know they're different. People in Texas and California think differently about a lot of things. So what is their, so what is their, how many people do we need to talk to estimate where they are with the death penalty within 2% of the true proportion at 90%? All right, so here would be the formula we would use. It looks very similar to the one before. It just has 2 things underneath the square root instead of 1. So it has M equals your z-score times the square root of P and 1 minus P over N and P2 over 1 minus P2 over N. Now, when you're doing these problems, you will often notice, and again, I'll have to check the homework to see if it's any different, but you will often notice that we're going to do what when we are looking for talking to people? We're going to have the same sample size. Like I'm not going to go to California and ask twice as many people as I do in Texas or vice versa. So since that's the case, what I can do then, since the denominators are the same, I can add these together. So we know from our previous experience, this is 0.25 and this is 0.25. So if I squish those babies together, I can make my life a little bit easier under the square root. So that does reduce down to 0.5 over N. I've already tested it, it works. Now, if somebody were smart and remembered our formula from last unit and is still fairly decent at algebra, they could see that this is the M, this is the Z, this is always going to be 0.5, right? Because we don't know what percentages are going to be there. And then this down here is the one thing I want. So if I do a bunch of algebra, I'm going to come back to, oh, didn't we do something like this? But what is really the only thing I'm changing? That looks very similar to the formula we had before. Instead of 0.25, though, I now have what? Use it if you want to use it. Don't if you don't. I'm just throwing that out there as if you want to make a shortcut for time purposes on any of these types of questions that come up, it's there. Again, you guys showed me this because you're smart about it. So I'm just hypothetically giving you guys a freebie. Okay, so let me clear my ink out of the way. You plug everything in, and there's your answer. You get 33,382 people from each state. Now, the only thing I have weird about this PowerPoint, and you may have caught it, you may have not have, is why is this different at this level than it was before? I don't know. I think it might be a typo or something weird. It's supposed to be 1.6449. That's what we used before, which caused me to get a different number. I got 3383, but it's okay. It's close enough. I'm going to ask Ms. Nichols about that later when I see her at lunch. So on the 2 proportions example 2, why is it 1.6448 when it's supposed to be 1.6449? She's usually very good at stuff, so if I find a mistake, I got to be evidence-based. All right, any questions on this one? Anybody need any help? You can type this all into the calculator, use my cheat formula, and it's right there. It's not really a cheat formula. It's just being smart with your algebra skills. All right, last thing we're going to talk about then, if you guys are good, is can I do a hypothesis test with two percentages now? Since we know how to do a confidence interval and we know how to do sample size determination, can we do a hypothesis test with it? Well, you betcha. A hypothesis test thing, it's right there in the program too. We don't have to do anything fancy. We just got to type in our stuff and we're going to press enter. We do have to talk about, though, how are our hypotheses going to be written, right? So now we're going to have HO and it's going to look a little different than previously because I don't have just P equals. I have two things. So I have to make sure I write these correctly. So I have two options. Either I'm saying that the difference between them equals 0, or I'm saying that they're equal exactly the same. So it doesn't matter which way you want to write it. You just have to kind of pick one format and stick with it so you get comfortable. Okay. And I'm going to explain that as we go through this. It's not going to matter if Connor likes one way and Zindi likes another way, they're going to get the same answer and they both mean the same thing. All right. If P1 minus P2 equals 0, that means they're the exact same number. So our original hypothesis, remember, has to be equal to something. So we're now comparing two percentages. So our original null hypothesis is now saying there is no difference between treatment 1 and treatment 2, or percentage 1 and percentage 2. Which means for our alternatives, we have different options. That P1 minus P2 is greater than 0, meaning that P1 is more effective or a larger percentage than percentage 2. That's one option. The other way is true, that P1 minus P2 is less than 0, meaning I get a negative number. Therefore, percentage 1 is smaller than percentage 2. Or the last one, they just don't equal each other because there's some sort of difference in there. We're testing a two-tailed test. And we don't care if it's greater than or less than, we just care that if it's different. Be sure to define both your P1 and your P2 using your where P is equal to da 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 da. I need to know, and so does the AP rater, and so does whoever's reading your test, what you're talking about. Questions on these? If you ask my preference, I use the ones on the right one. That's just me. You can use either one. All right, they're all listed there in your notes if you want to look at them. Since we assume that population proportions are equal in the null hypothesis, the variances are going to be equal. Therefore, we would use this fancy term called pooling the variances. If you ever take a graduate level statistics course, you will have to deal with pooling of the variances. We do not in this class because the calculator automatically does it for us. So zero stress on your guys' part for this. Don't worry about it. Okay. The pooling formula is the hot mess of the stuff that you see there, formulas for hypothesis test with two proportions. All right, so if you run in, if you're Googling these things, or you're trying to go to a master's, like I say, master's level class or graduate level class in college about statistics because you're really into this stuff, you will see a lot more about pooling. We don't really worry about it in here. It's not on the AP exam. The calculator does it, so you're good. But that would be the formula you would have to do to pool the variances for your p-hats. You'd have to take all those samples and do all that kind of stuff. But you're not going to have to do that this time. Yay us. All right, so here's our actual formulas that we have for our hypothesis test. Remembering, I don't have to write all of these out, but I just want to kind of explain the background information to you because I think understanding the whys and the hows is important. So our test statistic is Z. Remember, we're always trying to figure out what does Z equal, and we would say P1 minus P2 minus the actual P1 minus P2. Now, according to our hypothesis, what do we know about this right here? Our original hypothesis. These two should be nothing, right? Isn't that what our original hypothesis says? That it's equal to 0, that there's no difference between the two. So this part of the formula always gets erased, and you're left with this stuff down here. And then you've got to figure out what PC equals by pooling your data and you do all that. But we don't have to do all this because, again, our calculator is doing this for us. So this is why there's a lot of calculus stuff based in the background of statistics, because there's a lot of deriving of these formulas from the old stuff. Okay, but again, you're not gonna have to do all those. I'm just letting you guys know they're there. So let's look at example 3, our last example for the day. A forest in Oregon has an infestation of spruce moths. In an effort to control the moth, one area has been regularly sprayed from airplanes. In this area, a random sample of 495 spruce trees showed that 81 had been killed by moths. In a second nearby area, receives no treatment. In this area, a random sample of 518 spruce trees showed that 92 had been killed by the moth. Does the data indicate that the proportion of spruce trees killed by the moth is different for these areas? So that last sentence is the most important sentence here. Which way are we looking for? That there's just a difference. So when you set up your assumptions, you got to first start by labeling what is the test that we are doing. We are now doing a two proportion Z test. Why are we doing a Z test? Because we're doing percentages, not a T test. All right, we got our two assumptions. So remember, it is random because, menu item. Random because we have two independent, simple, random samples of spruce trees. Check. There's my first one. Makes me feel good. I'm put a little check there. There we go. And then we have to say normal because both distributions are approximately normal since or because. Why? N times P for, this is for the P1 here at the top, and this is for the P hat number 2 at the bottom. 495 times 81 over 495 equals 81, greater than 10. Check. 495 times 1 minus 81 over 495 equals 414, greater than 10. Check. Same thing down here. Check. Same thing right here. Check. So again, I write mine organized vertically. So if you looked at my paper, not that I'm going to show it real quick because you guys are writing, but I go ahead and I put the 495s on this side and the 518s on this side. There's no formatting way that's better than the other. It's just, I like to have my P1s on one side and my P2s on the other side. Miss Nichols or Miss Celine, whoever made the slide like that and go straight across. It's okay. Don't stress about it. You'll learn that when you do more statistics classes later on, if you choose to do so, that everybody likes to have their own weird, like, this is the way I do it. And so they teach you to use, that's the only right way. When I've seen it done so many ways now. All right, as you're going through here, remember you have to identify your hypotheses. Sorry for the words, they got a little off center. These would typically all be centered up over here on the right side. So what is my null hypothesis going to be? That they're equal. Remember, every time we do this, we assume that the percentages are the same. That's always our assumption. That's always the first null hypothesis. We never use the other symbols. So if I'm looking at this research, I'm assuming that there is no change in between the treatment and not treated area. What I'm testing for, and this helps us out with our error analysis, is number 2 there, HA. I'm testing if there is a difference, that they're not equal. It didn't say greater than or less than, so we use the not equal sign. So what kind of test is this going to be? Two-tailed test. Now, here's where you got to be fancy, and you have to define both of your percentages. So where P1 is the population proportion of all trees killed by moths in the treated area, and P2 is the population proportion of all trees killed by moths in the untreated area. So you have to define both of your percentages this time. All right, once you get your sentence written down, you have to include minimum items. So going back and looking at your notes for a hypothesis test with P percentages, you need to have your P hats on there in fraction form. So we're gonna have to write that on there. We need to put our critical value, our test statistic, our Z-score on there after we plug it through the formula. We need to write out what the P value is, and we need to write out what alpha is. So we're just gonna have a list of the numbers. I don't have to do the formulas. So I need to have those things in. And I'm going to show you guys how to get the Z, the P, and the alpha here, or the Z and the P value stuff in just a second. But you should have P hat number 1 is 81 over 495, and P hat number 2 is 92 over 518. We need to see the two different fractions. All right, so in the calculator, I got to look for where this one's at because you guys my first class to this one. So this is a 2 proportion Z test, I believe. Yes. All right, I'm gonna flip it over to camera mode real quick, and we'll come back to the screen there. So go to stats, go over to test, 2 proportions, because that's what we're on. We're not on samples. 2 proportion, and we're doing a Z test. So this is number 6. So if you want to write it down there, this is number 6. I don't know if that helps you out. So you got to type in everything. No, is this the right one? No, this is my numbers from the other one. 81 over 495. No, this is not even that. All right, so I'm gonna have to clear my numbers. You copied my numbers from the other one. All right, so what is my X value number 1? Well, P hat number 1 is gonna be 81. And what is the denominator for P hat number 1? 495. And then my X value for the other one is 92 and 518. Is that what you got as Indy? I saw you working on it earlier. Make sure I'm in the right area. Okay. Thank you. She was already working on it, so that's what I picked her. Now, here's where you can choose which one you're doing. Is P1 not equal to P2, less than P2, or greater than P2? So you don't have to tell it that I'm doing a two-tailed, I mean, you don't have to actually multiply the P value and all that stuff. You're going to tell it ahead of time what you're doing. So we're going to say not equal to in this particular case. And then you just go down here to calculate, and you should see all your answers there. So the Z score you need is 5598. What is that, a different number? Did I type in something weird? Why did I get weird stuff for? 5906, that's fine. You got this up here, right? Does not match the p-value we had on the notes. Oh, there it is right there. Okay, I'm looking at the wrong thing. Never mind. Yeah, we're good. It's the first time I'm looking at the program in like a year, so it took me a second. Sorry, guys. Everything's good. Everything's fine. Mr. G's panicking for no reason. Okay, so it tells you what you did on your test. P1 is different than P2. It lets you know what your Z-score was. So this was your test statistic. This is where on the graph your number placed, and then we would go what? We'd go back into the normal CDF. We'd plug this in as our upper limit. Our lower limit would be -1E99, and it'd come back and say, oh, this is your p-value. And there it is right there. So notice in the calculator, it just says p equals. But on your notes, or your work, you need to write p-value equals. All right, so you would say 0.5547. No need, don't even think about it. Don't even consider it. I shouldn't even say it. Do not multiply it by 2. It's already done for you. Somebody's gonna do it. Don't do it. Talking to whoever's thinking about doing it, don't do it. So 0.5547. So we're gonna compare this to our alpha. Did it give us a direction on what alpha is on this one? Nope. So we're just gonna use what? 0.05, just like we normally do. All right, so is everybody okay with the calculator? It's gonna save your life. Anybody got questions? Forever hold your peace if not. Somebody at home sleeping, watching their phone, I can feel it. All right, need the second wait list. Indy is my witness, so you guys yell at me later. Let's go ahead and put the conclusion at the bottom. So since the p-value is greater than alpha, I, we, you, whoever fails to reject the null hypothesis, there is not sufficient evidence to suggest that the population proportions of spruce trees killed by moths is different for the treated versus the untreated areas. So there's our Z-score we got from the calculator. There's our p-value we got from the calculator. And we're going to write out that for us, alpha is 0.05. So identify your level of significance. It is not written inside the paragraph. So if you're looking like, Mr. G, where did it say it? It didn't. So go back to what our rule was last unit. If no say, then keep it at 0.5. So again, what's kind of cool about these is I now have done a scientific experiment and I can see that the new spray, I'm not gonna waste my money on it. There's no difference in it. The trees are still getting eaten by the moths. So. That's it for the day, guys. What questions you got for me? Very good. All right, then things to keep in mind for the class period on Monday. First thing we're going to do is our air quiz. So go back, make sure you got that homework figured out. Let me know if you got any questions on that still. I have tutoring tomorrow at 2 to 3. If you got any last minute questions you want to go over, the homework for that is due at 11:59 p.m. on Sunday evening. So make sure you're taking care of that. After the quiz is over in class on Monday, we're going to spend the rest of the class time doing corrections on the multiple choice version of the test. And from what I am understanding, this includes people that made a above 70 grade. So if you made an 86, you can still do corrections on it. I will know all the details for you on Monday because the other classes are going to do it tomorrow. So they will work all the kinks out and they'll tell us what the rules are. So that's the plan. If you want to correct at any time your free response portion of the test, I do know what you need to do for that. You need to do corrections and make sure you understand all of your mistakes from the free response questions portion of the test. Get with me in tutoring or whatever it needs to do in order to get that done. And then you can set up a time with me to do the free response questions portion of the test on your own. We're not going to do that one in class on Monday because that one's a little bit different. That requires you doing the work, turning in the paper. You don't need that. So that's kind of the plan for Monday. Wednesday next week, we're not going to be here according to the current schedule. So you'll watch a video on how to do the hypothesis tests with means. Probably Miss Nichols recording it. So just, do what you got to do with it. And then we'll go over it and questions you guys have on Friday. And then you'll have time to work on the homework. That's pretty much it. We're not going to create something new for you in order just to keep you busy, like your other teachers are probably going to try to do. So that'll be Wednesday next week. And then on Friday, I can't remember what it is right now, but at some point a practice quiz is coming up over this and what you guys will learn next Wednesday. And we'll just test that kind of where you're at and how things are going. And you'll have that to keep with you in order to survive your test, so to speak. It shouldn't be that hard this time though. On April 1st. So mark on your calendars, April 1st, unit 7, or is that we're in? Yeah, unit 7 test, part 1, part 2, multiple choice free response questions. Anyways, that's kind of the plan going forward. If you guys are good at home, adios amigos. Have a good rest of your weekend and we'll see you on Monday for the quiz. They fly off faster than they sign in, man. I can't wait. Front page or back page? Oh, the one that I started. Okay, so this one's just asking you for your understanding of what's going to happen to the two errors. There is not actual math that you have to do here to like make a percentage. So basically it's saying what effect is going to happen to your type 1 and type 2 errors when you go from 50 drivers to 20 drivers in your sample size. So basically you're going from n is equal to 50 down to n is now equal to 20. So if you kind of remember at the very end of our slides last class, we showed the little graphs. They got skinnier as we added more samples to it, but they got wider and fatter as we had less samples to it. So whenever I decrease my sample size, the odds of both of these are going to increase. So I'm going to have a more likely chance, whatever that percentage is, of committing both a type 1 and or a type 2 error. Probably just one or the other, why not an and? So a type 1 or a type 2. Does that make sense? Kind of what I'm saying? So that kind of goes back to in your notes. That's kind of the opposite of this phrase here. Sort of kind of. So if you increase sample size, you increase the power, therefore you decrease all of your chances for errors. Remember, a very powerful test is doing its job more often than not. So by then the opposite would then indicate then if I decrease my sample size, then I would decrease my power, therefore increasing both alpha and beta chances. If that helps you out. That's all I'm really looking for in there. You don't have to actually go through and like do the math to prove it. You just have to say with a, if you want to be as statistically scientific as possible, you would say with a smaller sample size, my standard deviation would increase and therefore my probability of committing both type 1 and type 2 errors would increase. What you got, Mr. Connor? I guess technically that is correct. But I would say you're still going to have a chance for both of them because you're going to be less accurate. But yes, I was because your alpha itself is not going to change. It's a good point. I didn't think about that one. But because you're basing everything off of less accurate information, In theory, it's still gonna go up that way. Connor here, he's on top of his game. I like it. But anyways, I'm just looking for the fact that those are going to be more likely to happen. So for those curious about history, this was the last quiz I gave students last year in person before we started all of our COVID stuff. We've now made it 1 year. Not that that's really like something special, but just keeping track of historical events. This was the last. I gave this to them on Friday. This quiz is usually short. I gave it to them on that half day Friday before spring break. And they kept emailing me back in April, when are you going to grade that quiz? And then the AP people came in and said, we're not doing that anymore. I was like, so I'm not. So I never got to grade it. So this is the first year I'm going to get to look at how the grading goes on it. So anyways, fun times. We're now in uncharted territory. If you guys still have this available for you when you start doing the homework for the 2 part, we'll eventually have one of these sheets for the two sample inference sheets, but a lot of these things are still true, right? So you can still go back and use these as reference in case you're getting stuck and you want to go back into unit 6 and try to find everything. And then obviously the formulas are just a smidge more complicated, but the cool thing is you don't need them anymore. So we'll probably have a list of what it'll tell Laura, like this is program number 5, this is program letter B, this is program number whatever. So she has that as a reference. Because you won't have to add the tail. You don't have to do it makes life a little bit easier. So you can go back and look at these examples if you get really bored and you just want to really go over your statistical knowledge. You can go back and then kind of see like, oh yeah, that formula that's in the thing. It gave me the right answer if I just used that the first time, but Mr. G was too mean to share it with me, and now he's no longer even my half-liked teacher, much less my favorite. Ooh. A spam alert.